just a quick refresher on this. This is clearly a U sub question, but why is this? How do you know it's U sub? You know it's U sub because you can't simplify it. Algebraically, you can't do anything with this. So let's just recall what we did last time. U is equal to x cubed plus 1. Du is equal to 3x squared dx. Now, a good conversation that we had that I want to just address to all of you, something that you and I talked about, is when do we pull a constant out and when we don't? Right? So you can see right now we have a 3x squared dx. That is because I thought that was a really good, valid question. So there is no 3 here. There's no 3 right here because this is now our u and this is part of our du. So I do have to pull out the 1/3 in this particular question. And another thing that would really be helpful here is if you do highlighting, it's okay, well, my u is represented by that. My du is represented by this. And so there's my du. I still have that random 3 that we actually haven't dealt with. So that's why you have to pull it out. Is everyone okay with that? Does that make sense? Is everyone good with this? Okay, because sometimes if it had been 3x squared there, you would not pull out the 3. Okay, so we're going to just go ahead and pull out the 1/3. We're going to integrate this. Well, actually, we're going to do the integration of the square root of u du. So this is just a quick review on u substitution. And then we integrate u to the 1/2. That's supposed to be a 1, by the way. We integrate u to the 1/2. We get u to the 3/2. And remember, if we are going to divide by 3/2, we multiply by 2/3 plus c. Is everyone okay so far with this? Like I said, just as a quick review for everything we're doing here. And then I'm going to end up being 2/9. We're going to replace u with the x cubed plus 1 to the 3/2 power plus c. Okay? Now, how do we know that the u was x cubed plus 1? 2 reasons. Someone talk to me. Yeah.
The whole function is 2 to the power.
The whole function is raised to a power. That's a really good guess, and that's great. I mean, that's right. It's the right answer. I don't know why I said guess. That's right. The other one is what? The derivative. Yeah, minus the constant. We can always know the derivative is also setting there with it. Okay, so here is the first part. And like I said, most of this is just you practicing. I do want to say that for this next piece right here, we're just integrating mostly sine and cosine with a little secant squared right here. But what I want to say about part 1, so part 1 of this, so now we're learning how to integrate trig. Part 1 is that all of these examples, all of them, it's just one trig function. So the reason that I'm going to break it up into different parts is because each part is done. So all of these, there's only one trig function. Now, normally, and I can't think of an example right now, and I'm sure there will be one, the u for this, if u sub is the correct answer, and sometimes it's not, but the u is going to be your theta. So the u is going to be the theta. So let's talk about a couple of these problems and see what we can do with it. So I'm going to start with question number 1. And before I do that, let's refresh our memory on sine and cosine, because our sine, S-I-G-N, I want to make sure we're comfortable with this. So we want to just have a little part where we do this, sine, cosine, negative cosine, sine. And when we're integrating, because that's what we're doing on this page, we're going to go up with it. We're going to go up with it, okay? So let's do it this way. Now, we have to remember that every example you did, well, we haven't talked about trig functions yet, but if we integrated trig functions, I think we have actually integrated trig functions, right? You've learned that, but the theta has always been x. It's never been anything but x, because you have learned how to integrate trig functions before, right? I'm sure of that, right? Yes? Okay, so now look at all the thetas. The thetas are something different than x. So your u is going to be the 2x plus 1. Oh, sorry, minus 1, not plus. So it's going to be 2x minus 1. So check out what happens here, because when you're trying to do a u sub problem, you want it to be in the terms of some trig function u, cosine u. We're going to go ahead and take the derivative of this. So the derivative of this is 2 dx, and then we're going to pull out the 1/2. And let's look at what we have left. So we're going to have the 1/2 on the outside. If I go too fast, please let me know. So we have the 1/2 on the outside, then I'm left with cosine of u du in the inside. Because du is equal to dx, so therefore we have our dx right here, and again, I went ahead and substituted this in, because we know how to integrate cosine of u. The integration of cosine of u is the same as the cosine of x. So let's integrate cosine. So we go up to our handy little thing right here and say, okay, well the integration of cosine is going to be positive sine. We're going to go ahead and add our plus c. And the last thing we're going to do, and you already know this, is we're going to replace our u with 2x minus 1 plus c. Are we okay with this? I'm going to do 3 more, because I don't, like I said, I don't need to do all these questions for you. I'm going to do a couple more with you. I do just want to say that don't let something like this just make you distraught. It's x plus some number. So the derivative of this is still going to be 1. So you can make u equal to, so I'm not going to finish this question, but I just want to say that u is equal to x plus pi over 4. So your du is simply going to be dx. So when you actually do this problem, it's going to simplify down to that. Do you see that? So don't let that plus pi over 4, because pi over 4 is a number. So you make the sine of u, integrate sine of u, which ends up being negative cosine of u. I like that I said I wasn't going to do the question, and here I finished it out, but it is what it is. If it's x plus a number, this is always going to be du dx. Okay, so the last 3 I actually want to do are actually questions 6, 7, and 8, because they all have a specialness to them. And so I'm going to start with question number 7. Start with that one first. If you see this question, I want you to understand that probably your first bet when we get to more crazy integration is use substitution. Since you have one trig function, and as I said up here before, if you have one trig function, I'm going up here, one trig function, make your u equal to the square root of x, the theta. If that doesn't work out, then move on to something else. Move on to another strategy. Like I said, as we move through this course, we'll get to some questions where it doesn't necessarily work out, and we'll talk about what else we need to do as a group. So the derivative of this function is going to be 1 over 2 square root of x. You are probably used to me now just immediately going and talking about that derivative. This derivative is one of those that's really helpful for you to know right off the top of your head. The reason why students maybe get deterred by this is they see that question and they're like, okay, well, this looks weird, but look at what it is right here. There's your du. So we needed that square root in the denominator for this question to work out. But the one thing that's pesky about this question is we still need to get rid of that too. So we're going to pull out the 2. Is everyone okay so far with what I'm doing here? So if you see some function, so we're going to immediately go from 7 to 8 here in a second. If you see some function here, it's going to be okay because the derivative of this is going to be right there. So what do I do? So let's finish this question up. So I'm going to have my 2 on the outside. All I have left in my side, in my integral, is cosine of u du. Do we understand that? That I've actually, all of this rational function stuff has been gone away because it's been substituted by du. Everyone okay with this? Yeah.
Why is u the square root of x?
Because u is always, so for right now, and what you're going to learn in this section is u will always be your theta. So if it's one trig function, your theta is right there. So we want to make that because our derivative of the square root of x is actually 1 over 2 times the square root of x. And that's why that's there. So just make your u your theta. To finish this question up, we're going to integrate cosine. Again, I encourage you, especially while you get used to integration of stuff right here. When we integrate cosine, again, we're positive sine. So we're going to do this. We're going to get 2, and by the way, we would get 2 sine of u plus c, but let's just go ahead, save ourselves some time, and do the square root of x plus c. Okay? So then you should be able to do questions number 8, you should be able to do question number 9, and you should be able to do question number 10. So the last two I want to do actually not 6 and 8, I want to do 6 and 11. So let's look at question number 6. So this one's just going to take us back a little bit. By the way, any questions about this? I feel like if I'm going too fast, please let me know. I want to do 2 more of these and I want you to practice. Are you okay with what I've done? Okay. So again, you look at this question. The first thing I'm going to do is I'm going to pull out the 5. You don't have to do that initially, but I always suggest, like for question number 5 now, pull out that 3. You don't have to do it. You don't need to do it, but I like to do it because I just want to stick with what I know right here. So first thing I'm going to do here is, I'm kind of not sure what to do, but okay, well let's make u equal to 2x. Because again, that's the theta of our problem. So I'm getting to the point where I don't know if I need to keep showing this step, but I just want to make sure that people feel comfortable with this. So I have the 2 dx, and then I've got the 1/2 du dx here. I just want to say one more time, and then I'm going to break a record here. If this had been a 2, if that had been a 2 right there, you realize that, bless you, I could have still taken the 2 out here. I would still have the 1/2 here, and they would cancel each other out. So it's another thing you can actually think about doing is pulling out the constant, and then still having the 1/2, they're going to cancel each other out. If that somewhat makes sense to people, but I'm going to go ahead and change the problem back up. So the point I'm making here is this. Now that we have this, I'm going to have a 5 over 2. So make sure we understand that. I'm going to have a 5 over 2 outside my integral now. They don't have to match up. The 5 comes out because the 5's with the secant. The 1/2 comes out because when I do my derivative, I've got a 2 that I got to take care of. Is everyone okay with this? Then I'm left with secant squared u du. And this goes into the fact of, okay, well, we hopefully, now it's been a while since we've done this, but what trig function's derivative, because remember that's how you integrate, what trig function's derivative is secant squared? Tangent. It's tangent. Now if this is something else, which we're not going to do with you right now, then you, again, have a different method we want to do this in. But this is going to be tangent. Now if I give you like tangent squared u, then we've done something wrong, because these will always work out nicely for you. And so the final answer to this question is going to be 5 over 2 tangent. We're going to come back over here and substitute our u for 2x plus c. Is everyone okay with that? Okay, the last one I want to do with you is number 11. And then I'll let you guys practice. I try to do one of each type. But honestly, for number 11, I just want to rewrite this thing, because if you make u equal to 4x plus 1, so let's do that first. Because I told you, let's do that, and this is actually the right thing to do. Let's just play around with this one for a second. So every question I've done so far, every single problem that I've done thus far has always been u is equal to theta. And that's what is going to be true for all of these questions right here. So I have a 1 over 4, and we left with 1 over cosine squared of u du here. We don't know how to integrate 1 over cosine squared. But you learned back in pre-calculus, what is 1 over cosine equal to? Secant. So we're going to rewrite this as secant squared. And then we're back to example number 6. Right? We're not taking the derivatives of stuff. We're just integrating this. So our final answer here is going to be 1/4 tangent of 4x plus 1. How do we feel about this? It does get a little bit more complicated. I will tell you that in today's lesson. But before we get to slightly more complicated, not really, I want to just let you practice. I do not expect you to do every single one of these. But what I'd like for you to do is maybe do a handful of them, three of them with the people around you. Get your feet wet with these and see what you can do. So you have 2, 4, 5, 8, 9, and 10. I'm going to stop.